Good morning, sir.
Good morning. So fine. In last class, we have somebody sharing whiteboard. Okay, fine. In last class, we have drawn two network diagrams, and in those two network diagrams, we have chosen different IP series, right?
Yes, sir.
Okay, fine. Now, we will see the same thing with the help of packet tracer to get the output. And I think that two diagram was based on IPv4 and IPv6 both.
Right, sir.
Is that correct?
Right, sir.
Fine. Now I'm going to share my screen. My screen is visible to everyone?
Sir, it's visible.
Yes, sir.
Fine. Now I'm just going to take a switch. Switch is 2960. One switch and then second switch. Fine. As per diagram, I'm going to take 4 machines at each switch. Fine. Now, connect the machine. You can connect with any port. I have used 1, 2, 3, 4 ports. Fine. Same thing will be done at second switch. Any doubt?
No.
No, sir.
Okay, fine. Now we have to configure IP address. So just see your notes. Open your notebook in which you have written down everything. Now, I think in IPv4, first network was 192.168.0.0, right?
Yes.
Then the second IP will be 192.168.0.1. Second last IP will be 192.168.0.254. And last IP 192.168.0.255. Correct? Then this is the case of first network. Then network 2. For network 2, for second network 192.168.1.0. 192.168.1.1. Then second last IP 192.168.1.254. Last IP 192.168.1.255. Correct. From first of all, I am just going to take IP address from this network only, from network 1. In case of IPv4, then the IP 192.168.1.1, first valid IP. Then its default subnet mask is 255.255.255.0. Because this IP belongs to class C, and the default subnet mask of class C is 255.255.255.0. That's why it has taken, this value has been taken automatically. Clear?
Yes, sir.
Okay. Now, at second machine, 192.168.1.2. Fine. At third machine, 192.168.1. Sorry, 0.3. At fourth machine, 192.168.0.4.
Sir, in second node, sir, your IP is putting 192.168.1.
I was thinking that also. Fine, it is correct now.
Yes, sir, it is correct now.
Now, fine. Every node is in this first network. That's why, as per theory, these nodes should communicate to each other. These 4 nodes will communicate to each other.
Yes, sir.
Fine. So now I'm just going to ping from this machine to all these machines. Just at command prompt, ping second machine IP 192.168.0.2.
Why?
No, I'm not getting any response. Have I done any mistake in configuration of IP address? Yes, there is a mistake.
Yes, sir.
0. 5. Malcolm. Once again, I am going to think. Right now, I am getting reply.
Yes, sir. It is working.
Yes, sir. Also.
Now I'm going to ping third machine. Getting reply.
Yes, sir. It is working.
Fourth machine. Getting reply.
Yes.
Because all these 4 machines have same network IP address. Same network IP address. That's why these 4 machines are communicating to each other.
Yes, sir.
Now, if I'm going to change IP of these 2 machines, I'm going to put
One.
1 in place of 0. I'm going to put again 1 in place of 0.
It will
Then
not
what will
communicate each other. It will not communicate each other because the IP is not same.
There are IP do not belong to the same network.
Yes.
Now command prompt, again, I am going to ping 192.168.1.3.
Oh, okay. Request timing out.
Request timeout, request timeout.
Yes.
Now concept of different network is clear.
Yes, sir.
Everybody.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now this is the case of IPv4. Even if you will configure an IP address from class C, an IP address from class A, an IP address from class B, in this case also they will not communicate to each other, because for communication between different nodes should have same network IP. And in case you are using different network IP address, in that case there is no communication, and for communication you should implement router, because router is a device which has capacity to establish connection between 2 or more different network.
Right, sir.
Yes, sir. Right.
Fine. Then we have some IPv4 based class. Now I'm going to do the same thing, but now IP version will be IPv6. Okay. Now IPv6. Fine. Network 1. For first network, I'm going to use 2000:1234:1234:123. This is the network part.
Yes, sir.
And for host, I'm just going to use first IP, because in IPv6 all IP addresses are valid. There is no network IP, there is no broadcast IP.
Yes, sir.
Yes, sir.
Yes, sir.
Then 1234:1234:1234:1234.
Column B.
Find no colon B. This is the very first IP. And what will be the last IP? Last IP will be 2000:1234:1234. 1234 colon 1234 colon 123 A colon 1234 1234 colon 1234 colon 1234 colon 1234. Fine.
Yes, sir.
And network 2. Second network, in place of A, we will use only B. Then there is a change in network part, means there is this is the different network.
Yes, sir.
So 2000 colon 1234 colon 1234 colon 123 and 3. Then colon 1234 colon 1234 colon 1234 colon and 1234. This is the first IP. Same thing.
This is last IP, sir.
Last IP. Any doubt?
Yes, sir.
Now we have to configure this IP address at these machines,
Yes, sir.
at first machine. IP configuration, and this is IPv6. First IP 2000 colon 1234 colon 1234 colon 123
A
A
colon
colon 1234 colon 1234 colon 1234 colon 1234.
So copy them. Put them.
We can copy them. Fine.
Yes, sir.
Now I'm typing it for your convenience. And now IP prefix length. The default IP subnet prefix length or IP prefix length is
64.
64. Fine. This is the very first IP, and computer is accepting it because this IP is also valid in IPv6. But in case of IPv4,
It's not valid, sir.
this is not accepted. Fine.
Sir, what is your default gateway and link local address?
Yes, sorry. Link local IP address. I have given you idea that link local IP address starts from FE80. Now it is the starting, and this IP address is generated by system itself. If you have not configured any IPv6 address, then it has link local IP address, and with this IP address, it can perform tasks of any task.
So I can change the link local address.
No, we should not change it. Fine.
Yes, sir.
Okay. Let's see. Fine. At second machine, desktop, IP configuration, IPv6, and at last, we should remove 10 and put 1. Just second IP.
Yes, sir.
and 64.
Yes, sir.
And third machine, IP configuration, just
Oh, last
2,
3 or
64.
yes.
Now 3, because we have started from 0.
Yes, sir.
So 3,
Yes, sir.
64,
Yes, sir.
done.
Yes, sir.
Right now, we have taken all IP addresses from network 1. Now, these PCs should communicate to each other. I'm going to
Yes, sir. It is
command prompt. Now,
ping.
ping is here. No.
Paste. Control is
And second machine IP is P1. Correct?
yes.
Okay. We are getting reply.
Yes, sir.
2. Getting reply.
Yes.
3. Getting reply. Now,
Yes, sir.
I'm going to make change with these 2 machines. Click on this machine, IP configuration, or in place of A, I'm just going to put B. Fine. At this machine, B, then what will happen?
It will not work, sir.
Definitely.
It's showing, I think, request timeout.
To B, request timeout.
Yes, sir.
Fine. This is the concept of different network in IPv4 and IPv6. Okay. Now, in case of IPv4, very first IP of any network is used to represent a network IP address. If we will configure this IP address at a machine, then our machine will give us a information that this is an invalid address. I'm going to do this. In place of 1, just write it 0. Fine. Now, see, invalid IP for this subnet mask. Enter.
Why,
This
sir?
is invalid IP. Okay. Then I am going to put 192.168.0.255. The very last IP.
Yes, sir. It will work, sir.
No, not sir, invalid sir.
It is also invalid because this is used for broadcasting.
Broadcasting, yes sir, last IP.
Okay. Now, I'm going to take a value from reserved IP. Like reserved IP is 0.0.0. Class A.
It will not work, sir.
This is also invalid.
Yes.
I'm just proving it through the practical because I have given all these ideas during your theory lecture. But practically, you can see, okay, yes, this is really not accepted by the machine. Fine. And now I'm going to put 127.0.0. What will happen?
Will not work, sir.
Again, fine. So you all have Cisco packet tracer. If you have any idea about IP, or you would like to test your idea with some machine, you can do practicals very easy. Fine. Now this is the
Yes.
basic concept of IPv4 and IPv6. Fine. After this, now we are able to establish physical and logical both connections between machines. And we are using star topology. In a star topology, we have done physical connection. Now we have done logical configuration also. Now network is perfectly okay. Now what we have to do next? We have to do some more practicals, or some we should have some more concepts about the use of this. Okay, sir. In this way, we have established connection, we have configured IP address, our machines are communicating to each other, but we are just pinging, sir. And in ping, some packets are sent to the destination machine, and destination machine replies with some packets. So now we will study some more protocols like HTTP, HTTPS, DNS, DHCP, etc. First of all, I will cover DHCP because it is directly related to IP. What is DHCP? Most of the time I have used term DHCP. See, you all can see that there is a DHCP also.
Yes, sir.
And we are using static. Static means we have to configure IP address manually. But
Custom.
for a large network, it is not possible to configure IP address at multiple machines. If you are going to configure it, there is a chance of mistake. So in next class, we will start with DHCP.
Sir, which kind of mistakes, sir? Like repetition?
Like a repetition, typing mistake, anything.
Yes, sir.
Invalid.
Okay.
Sir, what do you tell about statics? Can you repeat again, sir? Could you?
In case of a static, we configure IP address manually. I have done. I have typed every IP address, no?
Yes, sir.
Okay, fine. So now I'm going to stop it.